So we're still on booklet 1 of Year 11 Structures and Bonding. We're now looking at giant covalent structures. They're called giant because there are millions of atoms in there, not just a few, and they're covalent structures with strong bonds between them. And they can be made from elements or compounds, but they're all non-metals. We'll start with diamond. Diamond is a giant lattice molecule. You can see the structure of it. It's a repeating pattern. It's called a tetrahedral structure because there's 4 bonds coming from each atom. You can see the carbon atoms there. Each red ball there is a carbon atom, and you can see it's got 4 bonds coming from it. It's a tetrahedral structure, and it's just repeated all the way down in a huge structure. That's what diamond looks like naturally. Very, very hard substance because you've got these millions of strong covalent bonds holding all the atoms together. Every carbon atom is bonded to 4 other carbon atoms in diamond. If you look at carbon on the periodic table, it's got 6 electrons altogether. The bottom number now we're looking at, the atomic number. So the electronic configuration would be 2, 4. It's got 4 electrons to bond with other atoms. So every carbon is bonded to 4 other carbons. It doesn't conduct electricity, but it's very good at conducting heat. It's very strong and hard due to the many strong covalent bonds in the structure. Graphite, on the other hand, again, is only made out of carbon atoms, but it's a totally different structure. Look. They're in layers, and they're hexagons. This is looking from the top, this is looking from the side, and they're in layers. These dotted lines here are weak forces holding the layers together, so the layers can slide over each other. Still made of carbon atoms, but differently arranged to diamond. Millions of these carbon atoms in a giant structure. But this time, every carbon atom is only bonded to 3 others. So you find a carbon atom here, 1, 2, 3. 1, 2, 3. Right? These layers go on forever, or go on for a long period of time. But there are weak forces locking between them. And graphite conducts electricity because there are free electrons between the layers that can move here between the dotted lines. And so they can carry the charge. Graphite is found in pencils. It's the inside of pencils. So when you mark on the piece of paper with your pencil, what's happening is the layers are sliding over each other. It's also a good lubricant because it can allow the layers to slide over each other. So it's like a dry oil because the layers will slide over each other. Diamond versus graphite, they both contain carbon atoms. They're allotropes, that's an important word. They're made from the same carbon atoms, but they're arranged differently. That's what an allotrope is. Diamond's very hard, graphite is soft and slippery. They both contain strong covalent bonds, but you need to know uses of each and properties needed for each use and explain the structure, how the structure helps it with that use. That's in the book, in the booklet, the Structures and Bonding booklet. Make sure you know uses and properties of each. There are many allotropes of carbon. We've just mentioned graphite and diamond. Don't worry about amorphous carbon. But in the booklet as well, there are fullerenes, carbon nanotubes and graphenes, and I've done PowerPoints on those. I haven't spoken over them, but there are questions on those PowerPoints that you need answering, and the PowerPoint will help you as well. But know that there are other allotropes of carbon, and know these are nanomaterials, graphene, nanotubes and fullerenes, okay? So there are other PowerPoints on the Year 11 study zone. So make sure those are done as well. Another giant covalent structure is silica. Now, it's not just containing one element, look. So you can have compounds that are giant covalent structures, but they're non-metals. So that is a compound, not an element, but it's still a giant covalent structure. So it would still have strong covalent bonds, high melting points for silica. Silica is actually found in sand. Sand is made up of silica.